Welcome back, guys. This is Latitude and Longitude. This is week 2, day 3. So we're gonna cover. First of all, that's your warm-up activity, which you just need to know the map tools from yesterday and Monday to answer these ones. Right here, you cannot see what they're asking, but in the presentation, it's in the right side here somewhere. Okay, so we're gonna go over some vocabulary. The globe, that's like a actual globe, like a circle. It's a map, but it's in a spherical circle. That's the closest thing that where the Earth gets represented correctly, uh, instead of a map. So we're gonna see right now the difference. So latitude, those are imaginary lines that run north or south of the equator. The equator is right through the middle of the Earth. So, and then longitude, those are imaginary lines that run east or west of the prime meridian. So that's in England, that's in Europe, that's where they start counting. So the grid, so when we have latitude and longitude, that's what you're gonna get for coordinates. Okay, and then hemisphere, that's just like half of the Earth. So hemi means the whole thing like this, like a half circle. Okay, now prime meridian, I already told you that's like that they count zero from there and they go in opposite directions. The equator, that's on the in the middle. That's how they count the latitude, and that's how they start like that 0 degrees. Now the degrees, that's how they measure them. So right here is zero, and then if you go up, it's north something, north something. If you go down, it's south something, and with the longitude also. So if you go this way, it's west. If you go this one, it's east. Okay, so we're gonna use globes and maps. Globes and maps combine place, location, and other features to help us understand Earth. Because Earth is a sphere, round, a globe shows shape, directions, and distances better than a flat map. So than flat maps. And the reason why, if you can see in the example here, just look at these ones over here in the north. They look bigger than they actually are, and it's the same here in the bottom. So if you look here, you cannot even see Antarctica, and here is like super huge. That's because they have the squared um, map distorts the real locations. So let's start with longitude. On on most globes, you can see two sets of lines. So that's on the ball, like this ball here. These lines run. The lines running between the North Pole and the South Pole are called lines of longitude. The longitude line at 0 degrees, it's called the prime meridian. So that will be this one right here. So it runs through England right here. So the area east of the prime meridian is called the eastern hemisphere, and then on the west is the western. So west, east. All right. So let's start with the next one. So now latitude. The globe is also divided into the northern and southern hemisphere. So if you look here, this is the southern hemisphere, this is the northern hemisphere. They start at 0 degrees here in the equator. If you go up, then it will be north 30, 55, whatever. And the same. It's I know it says negative, but it's really just south 30. Okay. So I'm gonna give you an example. So all of this is the northern hemisphere. All of this is the southern hemisphere, western hemisphere, and eastern hemisphere. So I put here the United States. Let's say Mexico. Mexico will be on the northern hemisphere, and it will be on the western hemisphere. So it will be in the northwest hemisphere. On the other side, Australia. So let's get something close. Maybe Madagascar. So Madagascar would be on the eastern hemisphere, and it will be on the southern hemisphere. So the degrees, that's how they measure this. So if you go up, it's 90. If you go down, it's also 90, but it's south. I know it's here, it's negative, but it's south and this is north. That's why you need your map tools. You need to see the labels. So to find a place on the map, you must know the location. So What we're really looking at here is absolute location. That's what we're looking with the degrees. Relative location would be something like, well, Texas is north of Mexico. Okay, yeah, that's good. But if you say then Texas is north of Canada, then that doesn't make a lot of sense. You have to look at absolute location. Okay, so after watching the video, answer some of the following questions. So I put some of them here, and just so you know, there's the screen right here. Okay. Oh no, it's not that one. It's this one right here. Okay, so let's go back over here. Now let's go to the next one. So this is for the coordinates. So I just put so you can practice some. I gave you Alaska. So Alaska is about, if you look at here, you start on zero. It's about 60 degrees, 62 degrees north. And then you count over here. So it's north. And then you go left. So it will be the west. It's about 150. So if you look at the answer, it's 62 degrees north, 150 west. And the same for Texas over here. I put Austin. So Austin, I know you cannot see it in the map here, but in the presentation you can just zoom it in. Let me see what's this. Okay, it's just for exit full screen. So Austin, if you look at here, it will be about 30, 31. So here's the 30. It's like 30, 31. And then over here, I cannot see, but I think it's like a 98. So if you go a little this way, it will be like a 97. So this is not absolute, but it's more or less. So it's north 31 degrees, west 97. That's where Austin is. Okay. And then you have to go play some um, coordinates game. I made my own. So I got 10 flags. So you have to go get your own 10 flags. And then to import it in, just when you're doing it, play the game. You have your 10 flags, and then print screen it, and you can save it into the slides like a picture. You just crop it out. Okay, so you just put it here. So from your computer, you can capture an image by pressing print screen and pasting it into the slides. Okay, and then just for the end of the lesson, so explain how latitude and longitude can help you find absolute locations. So we just covered this. You look at the map, how is it that it helps you? Now, how easy or difficult would it be to pinpoint a location on a globe, so on the big sphere, without using the coordinate system? So if you, it's kind of like if you had a book but it didn't have a glossary or chapters or anything. It's just a book with all the information. It's kind of hard if you just go back. So instead of having a guide, so explain what it would be. Okay. And I think that's the end of this presentation. So I'll leave you to do your homework and I'll see you tomorrow. Let's see.